All right, welcome to mathematics. On this series, we are still working on complex number. This is, go to my YouTube channel, subscribe. I think say Maths Academy, where mathematics is what is made easy. In our previous video, I talked about modulus of a complex number, and I gave you guys two examples. So I want to continue by giving you other two examples, and this part of it is very important. That was why I have to bring it. I don't need to leave it. Now let's get started. Now let's go into the solution of this number. Now, for example, when a complex number is given, if you observe very well, this is an imaginary complex number. It's an imaginary number. But you observe, recall that every complex number must be in the form of x plus iy or yi. And if you check very well, we have only a complex number here, only an imaginary number. Then where is our real number? Our real number is not known. Therefore, this implies that the question should have been 0 plus 6i, where our imaginary number is 0. So therefore, remember the formula for finding the what? The modulus. Finding the modulus, this is the formula, is equals to the square root of x squared plus y squared. So let us substitute. Remember, this is for x and this is y. So this is equal to, we have 0 squared plus 6 squared, which should give us 36. Which should give us what? Which should give us 6 as our final answer. It's a normal mathematics. All you just need to know that the complex number, forget about this, the I here. This is the formula. You replace this y here is replacing what? The imaginary number, the imaginary part. In our previous, I taught you how to find the Argand diagram of a complex number. So just substitute, forget about the I, substitute this 6 into the y and substitute 0 into this x. And you finally have that answer. Now let's go to the number 2 part of it. The number 2 part. We have z is equal to minus 9. All right. So we want to solve the second question. The second question, find the modulus of just a number. Now look at this value. This is just a real number. There is no imaginary part. So therefore, this implies it should be in this form. It should be in minus 9 plus 0. Our complex number here, or our complex number here, which is the imaginary number, is 0. So just like what we did here, but in this case, the real number was given, the imaginary number was not given. There's no I here. So we put it in this format. So this implies that z, the complex number, we have minus 9 squared plus 0 squared, which should give us the square root of 81, which should give us 9 as our final answer. Just like what we did at first, we only substitute into this formula. The real number was given to us, which is 9. The imaginary number was not given to us. We put 0. So when we square it, we got a final answer as this. All right, I told you I'm going to take you down to what? Argument. We are done with what? Modulus of a complex number. Now we are entering argument of a complex number. Now in this part now, we want to check the angle. The angle either in a radian form or in a degree form. That is what we are about to calculate presently now. We want to calculate the angle of a complex number. Either in radian form, we can convert from radian to what? To degree, or from degree to radian. So now we said the argument of a complex number is the angle, the line from the origin to the point xy makes with the positive real axis on the Argand diagram. In our previous video, you can go to my previous video and watch about Argand diagram. It's talking about representing a complex number in a graph. Representing a complex number in a graph. So the Argand aspect of it, we want to calculate the angle that was produced when two different complex numbers produce an angle. So when they produce an angle, we use this this pattern to check for the what? For the angle. Now it is donated by this. This is the format of writing an angle. Instead of writing argument of a complex number, it's just like a short form. Argument of a complex number. Remember, Z is a complex number. We always give us a theta. The theta is an angle given to us. That means we are going to convert from radian to what? To angle. Now the formula for the argument of a complex number is this. This was gotten from when we construct an angle, we got tan. When we construct an angle, we got tan. That is, theta is equals to the inverse of a tan, y over x. Remember, y is our complex, is our imaginary number, while x is our real number. So what we need to do is just for us to substitute the numbers into there. And I want to show you a diagram where after you have solved with this, you use the diagram to check, to convert from degree, or from degree to radian, or radian to degree. Now this is the diagram. If you check very well, we have radian here, we have degrees here. Now by the time we solve with that formula, we'll have a number. I will show you how to find it. Pi 2 is for what? Is for 90 degree. We have pi is for 180 degree. Then 2 pi is for 360 degree. So all these values here, by the time we get a number, I will show you how to use this diagram to get either your radian or your degree. This will be in radian form. All these pi 2, pi over 2, they are in radian form. Then all this number here, 140, all these ones, they are in degree. 90 degree, 70 degree. Then this one is all these upper parts, they are in radian. While this inside part is in degree. So we want to convert. I will show you a formula used to convert from degree to radian and from radian to degree. Well, we'll get to that stage. Wait. Oh, now. You want to collect something? Okay. So this is the formula to use to calculate for arguments of a diagram. Now, this is not just the formula. This one might not give us the exactly solution we might need, because some of the problem we'll solve, we discover that will not be correct. So I'm going to show you other patterns we are going to use to solve this problem. Now, because you must check the quadrant of the point x comma y, because the arctan formula alone does not give us the correct angle in all the quadrants. This is your quadrant. For example, now look at this. This is a quadrant. This is the first quadrant, second quadrant, third and fourth quadrant. So an angle found here might be exactly correct with this formula, but an angle found here might not be giving you exactly number. So what do? We use other formats. So there are only two formats used in finding the angle of a complex number. Now let's go to this one. Say notes. The quadrant rules. You have to know this rule by fire by force. Whether you're in the university, whether in the secondary school, this formula, if you want to cram it, you cram it. If you want to know it, you know it. The quadrant rules for argument. If I were you, even if I'm sleeping, I have to just be meditating. See it in my dream. So now, the first quadrant. What did my first quadrant say? My first quadrant says, if my real number is greater than 0 and my imaginary number is greater than 0, I will use this formula by fire by force. This is the formula you have to use. My second quadrant says, don't worry, we are going to solve problems after this part. We are going to use it to solve problems. My second quadrant says, if I find it, like look at, let me draw the quadrant again. If I find my angle at my first quadrant, it says, for me to know that it's in my first quadrant, my imaginary number must be greater than 0, and my real number must also be greater than 0. I'm going to use this formula. My second quadrant, how will I know that I'm into my second quadrant? If and only if my real number is lesser than 0. You know, number that is lesser than 0, minus 1, minus 2. If my real number has minus, and my imaginary number is greater than 0, oh, it falls under the second quadrant. My third quadrant, Nobody will tell you that, oh, this question is your third quadrant. You will know it from the sign given to us. My third quadrant says, if my real number is lesser than 0 and my imaginary number too is lesser than 0, it means I'm to use this formula. What is the formula? Minus pi plus tan inverse of the number given to us. Anything, we'll just substitute this minus pi. This minus pi, mostly we use 3.14. We use that one. We are good to go because we are converting to what? To degree. But if it is radian, there's a way I'm going to show you how to get for radian. We are going to use that table to find radian. Now let's go to the last quadrant. If you are looking for the last quadrant will always tell you that for you to know the last quadrant, x, which is your real number, must be lesser than 0. And your what? Your real number must be lesser than 0. And what? Your imaginary number must also be what? Must also be lesser than what? 0. So once it's lesser than 0, you use this word, this formula. And this formula now, you observe there is no pi here. You just use this. And this answer must not be negative. The answer will be what? In negative. It must always be negative. This fourth quadrant, it must always be negative. The reason is because if you check very well, all this part of it is negative numbers. So it must be what? In negative value. So let's get started by solving some problem using this argument of a complex number, using this format. We are going to use this formula. In short, if I were you, forget about just focus on this quadrat rule, because the first rule has already covered this rule we are to use. This first rule has already covered it. So let us use these rules to solve problems on argument of a complex number. All right. Now, like I told you, this place here, correct this place. This fourth quadrant is when the real number is greater than what? 0, and your imaginary number is lesser than 0. Observe that these two are not the same thing. Now let's solve some problems. Examples. Find a